Okay, so let's start. Well, we've got the last non-calc, and it's the most recent one. So it's from it'll be about last August or July time, which is when they kind of brought the new batch out. So hopefully within the next couple of months, NCFE will give me some new things to look at because sometimes when you've been looking at the same papers now for 6 months, it kind of takes that not edge away from it, but it takes that level of, oh, I'm not sure what to do on this one. So yeah, the more you look at the current papers that are online, the better it'll equip you for the ones that you're going to do in your real exam, but it won't be exactly the same. But you'll get a gist of what sort of an average question might be or what sort of percentage question might be. So yeah, I would say the more time you spend on these past papers, the better it will equip you. So let's have a look at what it's got to offer us. Right, we've got 7 questions. So normally it's 6, but today is 7. We've got 30 minutes. We'll have a quick 30-second look. We've got a 1 mark, a 3 mark, a 2 mark, a 4 mark, wow, a 2 mark, a 1, and a 2. So there's nothing major. There's a 4 in there, but there's no 6s or no 5s. So let's have a go. Mr. Aldridge is a science teacher. He finds this information on the solar system. The distance from the sun to the Pluto is 5.9 billion kilometers, right? 5.9 billion is a number. So my advice to anybody doing this question is write a million first, and then you know that the billion is the 3 zeros where that should be, and then the 3 zeros there. So that's a billion. And then if we put 9.5, so we've got 9.5, and then it's a billion like that. So we've got 9.5 billion. It's 9, then a 5, and then 8 zeros. So we've got to write it as a number 9, 5, 1, 2, 1, 2, 3, 1, 2, 3. I wouldn't do this if I'm comfortable doing the spaces because then I can see where I'm up to, but you wouldn't get penalized for not putting spaces. It's just sometimes.
So billion is how many numbers?
It's 9 zeros. Is 1 billion is 1 and then 9 zeros. It's basically 1,000 million.
Yeah. Okay.
So yeah, remember it's just
sometimes it can be confusing. Yeah.
Yeah, it's just an extra 3 zeros. If you think that's a million, then work up. So you've got 1,000. So 1 million, and then a billion is 1,000 million. So then we need 9.5 of those billions. So yeah, for me,
like 9.5.
Yeah, putting the zeros with a space helps me recognize that I've got 9 digits after my first digit.
Yeah.
The distance between the sun and the earth is 149.6 million kilometers. The speed of light is 299,729 kilometers per second. Mr. Aldridge uses estimation to work out how many seconds it takes the light from the sun to reach the earth. He thinks it's 5,000 seconds. Is he correct? So we've got a yes or no for our third point. Use estimation. So the key phrase there is use estimation. It's 149,600,000. We're going to estimate. So we're going to make
150.
Yeah, 150. We've got that. And then the next number 299,729. That would become absolutely. So we've now got 2 easier numbers, and if we drop them down below, we can see that 150. We'll put them now in kind of more direct line. 1, 2, 3, and then 300,000, which is here. So we can clearly see now the relationship between these numbers. We need to divide distance. So it's that triangle there, distance, speed, time. We've got the distance and we've got the speed. So it's distance divided by speed. Distance divided by speed equals time. That little triangle. Distance is always on top, and the S and the T makes no difference which way around the S and T are, because whichever one you're trying to find, you just divide distance by the other. So I'm going to look at those 2 numbers and think, right, the easy way to do that is chop off both those numbers, and now it becomes 15 100 divided by 3. And that's much more simple because we just go 3 into 15 goes 5 times. 3 into 0 is 0. 3 into 0 is 0. So we've got 500, and it's exactly the same as what it would have been had we put all those numbers in a calculator, because we've just...
Okay, so but it says 5,000, which is
wrong. Yeah, so Mr. Aldridge is wrong, incorrect, as it is 500 seconds. And then on here, I would show them exactly what I've done. I've took 149,600 to 150, 1, 2, 3, 1, 2. That's that one. And then we've got the next one was, I've put an extra 0 in there. Oh, yeah, I have. Then we got, 299,729 goes to 300. And we've just done 1, 5.
That's too much 0.
Yeah. 1, 2, 5, 1, 2, 1, 2, 1, 2, 3 divided by 300. 1, 2, 1, 2, 3, and then we change that to 1,500 divided by 3. What we do equals 500. I probably wouldn't even put those bits in there. I will probably just show. I've done 2 minutes. I'd probably just show what I've rounded them up to. It's much easier that way, and then you can clearly see that you've rounded them up, and you're just going to do the action.
Yeah.
Yeah, that's where I'd go with that one. Mr. Aldridge asks his students to compare the distances of galaxies from the Milky Way, distances between the galaxies, and this is where this particular exam really winds me up, because it's talking about, I don't know much about astronomy, and it's never been kind of something that I'm like, oh wow, that's really interesting. So I find it hard sometimes to do the math on a topic I'm not that interested in. So distance between galaxies are measured in megaparsec units, MPC. Do I really care? No. The Andromeda galaxy is 0.52 MPC from the Milky Way. The Pinwheel galaxy is 5.1 times further. Yeah, it says, what is the distance of the Pinwheel galaxy from the Milky Way? So in theory, after all that, for 2 marks, it's saying, can you calculate 0.752 times by 5.1? That's what it's asking us to do, but it's given us a lot of complicated words.
And make it 2 decimal points, yeah.
Yes. So how I'm going to do that, I'm going to look at this number. I'm going to change things here. I'm going to ramp up, and I do this on every time. Every time I see a decimal, I'm going to go 1, 2, 3. So I've put 3 decimal places at that one, so that becomes 7, 5, 2. And I'm going to put 1 on there, 1 dp. So that becomes 51. And I know when I've got my answer, I've got to put back in 4 decimal places back into my answer. And it just makes it, for me, it makes it a straightforward multiplication sum where I know it's just a double number. So I've got a 0. That's the only thing I'm adding there. So 2 times 1 is 2. 5 times 1 is 5. 7 times 1 is 7. Then I've got my 0. 2 times 5 is 10. 5 times 5 is 25. Add my spare is 26. 7 times 5 is 35. Add my 2 spare is 37. So I've now got my 2 numbers I need to add up. 2 add 0 is 2. 5 add 0 is 5. 7 add 6 is 13. 1 add 7 is 8. And 3 add nothing is 3. So I've now got a number here. 3, 8, 3, 5, 2. And that's where my decimal place would then come in. So it's asking me what it is to 2 decimal places. So let's work it out what our number is now. We took 4 decimal places out, so we put them back in. So we're going to go 1, 2, 3, 4. Okay, so our new number, if we'd have done that on a calculator, which we're not allowed because it's non-calc, would have been 3.8352. It says do it to 2 decimal places. That's that number there. So this one becomes a decision maker, and as we're going to see, it's 5 or above, we go up, and if it's 4 or less, we stay the same. It's a 5, so that becomes 3.84, and that's my answer for 2 marks in there. 3.84 For my
Did you
answer,
get 3? Did you get 3 points? Is it 3.8?
yes,
The calculation you did there, is it okay? Let me see.
3.84. Have I got it wrong? Have I done it wrong here? 2, 5, 13, 13, 8.
Okay. Yeah, you're good.
Good. And so on my bits here to get my extra mark, I would have just done here 0.752 times by, I've just shown them what I'm going to do, 5.1 equals the full answer, 3.8352, and then round it up to 2dp will be 3.84. I wouldn't put anything else in other than that in there. There's no need. You've done it. I've done it my way, but I've just clearly shown that I understand that it's those two numbers multiplied together.
Okay.
And again, I find this question, it's quite not complicated because it's about ratios, but the way it's kind of saying Mars and Pluto, I think it's just me that kind of has a barrier against kind of astrology and planets. I don't really know much about it, so I find the questions quite hard. Mr. Aldridge wants his students to compare the temperature of planets. He reads the mean temperature, on Mars is -65. The ratio of the mean to Mars to the mean on Pluto is 13 to 46. So we know Mars is 13 and we know Pluto is 46. We know the mean on Mars is -65. So we now need to work out the ratio of those two numbers. And it says here, Mr. Aldridge thinks that the mean temperature on Pluto is 275 degrees colder than the mean temperature on Mars. So 275 degrees colder than that would be literally -275 and then 65, add them together. And if you look at that, that becomes, what is that? That's a 0, 1, that's 13, that's 14. So he's saying it's going to be minus 340 degrees on Pluto. That's what we're looking at. So let's have a look at how we're going to do this sum. We know that of our ratio, it's saying that 13 parts is -65. So if we divide 65 by 13, we'll know what 1 part is. So if we do the 13s times table, which obviously we're at school, we only got up to 12, but if we go 13, 26, 39, 52, 65, we can see it's a direct match. So 13 into 65 goes 5 times. So we can see that 1 part equals -5. So we've just broken that into 13 equal parts. So we know that 1 part is -5. We now need 46 parts to work out this magic number here. So the magic number would be 46 multiplied by, I know it's -5, but I'm going to put 5 and I'll put the minus number in the bottom because I know it's minus. I don't need to put -5 there. So I've got 6 times 5 is 30. 4 times 5 is 20. Add my spares would be make it 23. And it's a minus because I've got 1 positive number, 1 minus number, and that means that the negative stays the strongest. If it's a negative times a negative, it changes to a positive. And obviously if it's a positive times a positive, it remains positive. But if you've only got 1 negative within your sum, the answer remains negative. So the temperature on Pluto is -230. Is it 340 degrees? Is it 275 degrees colder? No, because we're over 100. You know, it's 110 degrees warmer. It's still -230, so it's still chilly. It feels about as cold as my kitchen at the minute. So the answer for this one, is he correct? Incorrect. And I'm not saying why. I'm just going to put my workings out here. I'm going to put 65. I'm going to put here 13 ratio of 46. I'm going to try and keep my numbers underneath it. So 65 ratio is question mark, and then I'm going to put 65 divided by 13 equals 5, and then 5 times 46 Actually, I'll put my equals, oh my gosh, equals 230. Temp Pluto temp is minus 230. So if you look at the difference between those two temperatures, we've got 65 up to 100, that's 35, and then up to so that's 165 is the difference. 165. So so only 165 colder. And the way they've kind of tried to play tricks in your head is if that's 230 and that one is normal 65. So people, they're trying to play tricks, and so you're showing you understand that negative numbers, two negative numbers below zero are both here, whereas if one's above zero, the gap's much bigger. So if it had been minus 65 and plus 230, we'd have had a gap of 295. So that would have been correct, but because we've got two negatives, we're both with zeros here, and we've got a negative minus 65 and a negative minus 230. The gap, oh, sorry, just whacking my plant. The gap is only between minus 65 and minus 230, so therefore it's less, much less. So that's where that one doesn't play tricks, but it makes you read the question again and thinking, right, oh, that's a bit
The
naughty.
question is quite tricky, to be honest.
Yeah, there's
Because I wouldn't know I know that is a ratio, but it's really different from the ratio that I know. So I wouldn't know that I will have to um divide that 13, because the ratio I know usually you plus and divide.
ah yeah,
Yeah,
so yeah, so
it's quite
you're
tricky.
thinking, yeah, you're thinking of it. So with some ratio questions, you're right. You have a whole number, then you add
Yeah,
your two little ratios together to find
yeah,
out.
yeah.
Yeah, so this one's a bit sneaky in the fact that it's telling you
Yeah,
the
it's
value
quite
of,
tricky, to be honest. That's
yeah,
why I'm really looking at it to say, okay, so if I have something like this, that I know what to do.
yeah, it's telling
Um,
you the value of one of your pieces of your ratio, so you don't worry about that piece to start with. So say if
mm,
it said, the 46 pieces was 250, for example, find out
mm,
what this one is, we
mm,
divide 250 by 46. So whichever side it's telling you the information for,
mm.
it's always going to give you information for either all of it, like you suggested there, and we add the ratios up to divide by, or
Yeah,
it'll give you some information about one of
one
the
side.
sides, and you've got to
Okay.
find out the mystery side. It's almost like
Mm,
finding a mystery number. So it's just
wow.
identifying which bit, what is it asking me, and then
Mm.
having another look. But yeah, sometimes ratios can be tricky like that.
It is very tricky. And then, given exam situation, do you really have that time to start thinking, okay,
well, that's the
what
hard. I
am I
mean,
looking for right here? What am I
yeah,
looking for? You just, I mean, it's really, I don't know
I get that.
whether they are making the students, they are setting them up to fail. Because
Yeah, but that question. I mean,
exam situation, you want to look at the question and say, oh, okay, right, this is this, okay,
yeah.
this is what I'm supposed to do. But when you have to pause and say, okay, what do they want me to do? What am I going to do? How am I going to work this out?
I
If
like that. But the thing
And
is,
then the time is going, you
yeah,
know.
the more you look at these questions, though, the more you'll be prepared. And the thing is, on this particular non-calc, when we look through the starter, we saw that one question there we've just done was the hardest.
Mm,
It's the longest question. So maybe, some people attack the hardest ones first, which obviously, if I'm in an exam, I want to have a quick peek at all my questions, but I would still try and do them chronologically because I like order. So
mm,
for me, doing them all over random would throw my brain. So yeah, I do think it's worth having a look at the questions and thinking, right, what can I do first?
yeah,
Oh, that one's
yeah.
a hard one. Let me have a
Mm,
go. Because sometimes they put the hard one last. I'm like, oh my gosh, why would you do that?
mm.
Okay, so the length of one day on the moon is 24 hours. Mr. Aldridge thinks that this is 3% of the one day of the moon. So he's saying Earth is 24. Earth is, oh my gosh, why would I put 26? I don't even know why I put 26 there. That is bizarre. Earth is 24. and that represents 3%. So we've got the moon. That is a mystery number, and that is 100%. So we've got our little triangle going on here again, our little square, sorry, we've got that little square going on here. So if we do this one here, we're going to go 24 divided by 3 times by 100 will equal that number, because we're finding out the 1% number. 24 divided by 3 equals 8. That's our 1% number. That's here. Then if we want our 100% number, we just times 8 times 100, which will be 800. So for me, that question, when we, again, it's all about getting used to setting it out on my pad of paper. So this is my pad of paper, getting used to setting it out quickly and in a process that you can then action the question straight away. So I've taken that information here, I've written what we've got, and I've said here, this is the mystery number this time. How do I get to that mystery number? And I've gone, I figured it's a direct proportion question, isn't it? If that represents 3%, what number represents 100%? So we find out what 1% is, and then we just multiply it by 100. So my working out for 2 marks here will be fairly straightforward. 24 divided by 3 equals 8. 8 times 100, well, 8 times 100 equals 800. Space for working out, 800, done. And I wouldn't worry about my little my little primary school window there. Another 1 marker. So it's given us a couple of easy ones just to get back into the swing of things. F. 71% of the Earth's surface is covered in water, and the rest of the Earth's surface is land. What is the probability that a meteorite will crash into the Earth and land on land? So it's saying here, Earth. We're saying here, that's not 71. Well, that's about 71%. 71% is water. The whole Earth is 100%. So 100 take away 71 equals land. 100 take away 71 is 29. So we know that little extra part there. And you might, I mean, some people wouldn't even look at that and think, oh, I don't need to write anything down, because I know that 100 take away 71 equals 29. 29 in my box. Done. So it's got a 29% chance of landing on, crashing to land on Earth. That's a bit of a mouthful.
The last time I did it, yeah. So if you do it 29 over 100, is this still okay?
If you said 29 over 100, like,
Yeah.
you mean if you, yeah, that's a
The
fraction.
probability.
That's absolutely fine. Yeah, or you'd say 0.29, or you'd say 29%. So they are all the same.
Okay. All right.
So yeah, you'd get the point for the equivalent. It does not say, can you show your number as a fraction or as a percentage? So yeah, you'd get the mark for representing it however you see it first. So yeah, that's not a problem. What have we got next? NASA lost a spacecraft due to confusion, doesn't surprise me, between imperial units and metric units. Another confusing life story. What is the difference between, why do we have inches and millimeters and centimeters? Why can't we just have 1? A length of 2 3/8 inches was read as 2 3/8 centimeters. 2 3/8 centimeters equals 6 13/400. Work out. So after all that, again, a story for nothing. Work out 6 13/400. Take away 2 3/8.
Okay.
So after all that, we don't care about NASA. We don't care about the getting confused imperial metric. We just care about the sum.
Yeah, the question is work out that.
Yeah, so first of all, we're going to make both improper. So we're going to make both improper. They're mixed numbers at the minute, so we need to go whole times bottom, add top. So it's big number, 6 times 400 is 2,400. Add 13, 2,413. 400ths. Okay, that's that one. Minus 2 times 8, which is 16. Add our spares is 19. So we got that question. Once we've got that question, we need to now make them both here the same denominator. If my brain tells me correctly, I'm saying that 8 divides into 400. So I'm going to keep that one as a 400er. I'm happy with that. Okay. And then I've got to take away, I'm going to change this one to 400 as well. So whatever I did to this number, I need to do to this number. And 8 times something, 8 times 5 is 40. So 8 times 50 is 400. So 19 times 50 is going to be my number to go on top. So 19 times 50.
Steve, I lost you there. I don't know what you did there. I'm
Okay,
sorry.
okay. Let's go
Okay,
back.
so let's start with the improper. So 6 times 400, right?
Yes, so from improper, right? So from an improper to a
From mixed
so
to triple. Yeah,
from a mixed number to improper. So mixed, let's go here, mixed to improper. You go whole number
yeah.
times by
The
denominator,
bottom. Yeah.
denom. I'll put demon, and not really demon.
Plus the top.
Add, yeah, add numerator. And that's what it is. So it's whole number times by denominator. So it's 6 times 400. So 6 times 4 is 24. Add our 13, 2,413. Keep the 400. 2 times 8 is 16. Add our 3 on top, 19. So they are now our improper fractions.
All right. Okay.
From there, we need to make them both into the same denominator so we can just do a simple subtraction. I'm keeping 400 because 8 goes into 400, so I'm keeping that one as it is. I'm not having to do anything with that at all. With this one, I've now understood that to get from 8 to 400, I have to multiply it by 50. And the reason I know it's 50 is because 8 times 5 is 40.
40.
So 19 times 50, I'm going to try and switch it into there, times by 50 is going to be my top number. So 19 times by 50. I'm just going to go 19 times 5 and add a 0 on the end. So, and it makes it much easier. I don't have to do a double multiplication. 5 times 9 is 45. 45, I'll put 54 then. That's a 6 times 9. Right, so 5 times 9 is 45. 1 times 5 is 5. Add my spares is 9. Okay, so, and then I'm going to add the 0 back in there, so it becomes 950. So I've got 950 400ths minus from my bigger number here, look. So minus 950. The 400s stay the same, they don't change. 3 take away 0 remains at 3. 1 take away 5 I can't do. 11 take away 5 I can, that becomes 6. 3 take away 9 I can't do. 13 take away 9 becomes a 4. And then 1 take away 0 remains 1. So my answer to that question is 1, 4, 6, 3, 400ths as a improper fraction. We're now going to make it back into a proper mixed number. So we'll scroll down a little bit. So we go 400, 400, 400. I've got 3 whole ones because that equals 1200. So I know I've got 3 whole ones. That'll be 1200. And then I can see I've got 2, 6, 3, 400s left. And if I want to kind of double check my workings, I go 3 times 400, which is 1200. Add my 263, which is 1463. So my answer here is 3 and then 263 400ths. My workings out are exactly what I've done here. I'm going to say that 2, where we go? So we're going to have 6 and 13, 13 400ths is 2,413 400ths. And then 2 and 3 eighths is 19 eighths. Then we're going to put on here 19 eighths. 19 eighths is 950 4 hundredths. 2000, no, 2413 minus 950 equals 1463. So then we got 1463 4 hundredths is 2, and then 263 4 hundredths. Okay, and I'm not even going to attempt to shrink that fraction. I don't think it doesn't divide by 2 because that's obviously an odd number. Does it divide by 3? Well, that one might do, but 400 doesn't. So yeah, I'm looking at 5s, definitely not. 7s, no. 8s, oh yeah, it's going on, that don't go 8. So I'm looking at numbers that there's no point even wasting time thinking about that. Right, so we're going to run out of time. I can't pause it, but we can look at the answers. So if we wait till that runs out in 30, no, we don't need to wait till it runs out in 30 seconds. We just check our answers on the marking scheme. Okay, so let's scroll up to some of our workings out and then look at what they say. Can I make that a little bit bigger? Yeah, I can. Okay, let's have a look at what. I still can't. That's been on my computer now for a week and I don't know what it is. So if anybody's watching this video back and they know what that means on my computer, because I've never pressed it, and I
What is that?
don't know. It's just some sort of thing that appears on my screen.
That thing there, okay.
Yeah,
I don't
know what it is. So and I don't press it in case like my computer like suddenly goes, "Ooh, virus!" Woo, woo.
Does it move around?
If I've got it's always on my computer. So when I open the internet, it's always there, and I'm thinking, is it like a McAfee, what you want to call it? Like, is it a protector for my computer, an antivirus thing? But I don't click on it in case suddenly it just wrecks my computer. So yeah, it's while it's there, I feel protected. But yeah, I don't click it in case suddenly my computer just conks out. Right.
Okay.
So we have got, where are we at? Did it say? Did I read that number wrong? Is that my reading again?
Which one?
Did it say 5.9 billion or 9.5?
No, it says, I think it was, is it 5.9 or 9.5? We did 9.5, to be honest.
We did, yeah, but I don't think it is. I think it's 5.9.
Oh, okay. Well,
that's
okay.
it. So that, and again, that does kind of go to show that when I'm reading, often it's vowels I get mixed up. So when I'm reading, I get the vowels mixed up. I wouldn't say, oh yeah, I'm mega dyslexic, but quite often numbers don't normally impact me. But if I've read that wrong, how bonkers is that for the first question? It's one marker, and I'm like, I'll be gutted. Let's have a look. Come on, next question. 5.9. What? So yeah, okay. So we read the number.
Okay.
Well, I've written the number 9.5 correct. I just didn't. I just got the wrong number. That is a pain.
Oh well, no. The thing is that we wrote the billion correctly.
Yeah, and I must have said 9.5 billion probably 6 or 7 times. So
yeah, it's okay. The idea is getting the zeros correctly anyway.
Thanks. Yeah, it makes me feel good. Okay, then we had the rounding of numbers up. We rounded them both up. We rounded the 149.6 to 150.
Yeah.
We rounded the 299,730 up to 300. And so we've got a rounded figure of 1,500 divided by 3, and therefore we have 500. And that is the answer, 500 seconds. So it's a no. We said no. Then we had the not straightforward multiplication because we had lots of decimal places in there. For me, I got rid of all my decimal places, like I did here, 3 decimal places for that number, 1 decimal place for that number. Wrote a reminder on the side to remember. Okay. Yeah. Okay. 3.84
even if you leave it at 3.8352, it's still okay.
You'd have got one.
They said in 2 decimal places, isn't it?
You'd have got 1 mark for that, so you'd have missed the second mark because you'd have worked out the correct sum, but
Yeah.
you wouldn't have rounded it up to those two decimal places there.
Yeah,
So it's important
because
that
he said you should round it up to two
yeah.
decimal places. Okay.
So
Okay.
yeah, changing that 3 to a 4
Mm.
is the second mark.
All right.
And then the most difficult question on the paper was the ratio one. And it's difficult because again we're dealing with minuses a lot. It's like
Mm.
I, I don't I don't particularly like the question, but if you look at this one here, we've done 65 and it's kept it as a minus in brackets divided by 13, which we said yes was 5. Then they've times it by 46. So yes, they've got minus 230. Yes, we have. And they've done the difference between minus 230 and minus 65 is 165, which we just said that it's actually much less than minus 275. So the answer would be no, it's not. And it says there, look, they've got the 340 there. So we did say that if it was minus 275 degrees colder, we'd be looking for a temperature of
340. Yeah.
minus 340. So yeah, we're good for that one. And there's different ways of doing it. They've done a reverse process there. I'm not going to confuse myself by doing it a different way and thinking, oh yeah, that's cool. We did the moon's day length. We set it out quite quickly in a little primary school window technique. We knew that because it's direct proportion, 24, and then 3 goes directly underneath that. And then we found out what 1% was by dividing 24 by 3, which was 8. And then we times it by 100 to get the moon. Again, some people might not even need to put any of that working out. They can just instantly think, oh, right, 24 divided by 3 is 8 times by 100. But because it's a 2-pointer, it's important that you write something in there because you want both marks. And if you've done it somehow, you've done it somehow. So that's all I would do. 24 divided by 3 times by 100 and done. They've done it slightly different. They've done 24 divided by 0.03. That's exactly the same as doing what we've done. They've just put the double zeros on here. And I don't see to I don't know. I never really do that. I know it's 2 steps because I'm times it by 100 in my head, but I'm okay with that. I'm all right. So yeah. Right, let's go next one. F, we said, like you said, they would accept anything that represents the probability.
The way I did it the first time I tried it was okay. So they said water was 71% and the whole earth is 100. I just deducted 71 from 100. The 29%
Yep.
is the probability. That is
Yep.
where the probability will happen. So it's 29 over 100. Then I just leave it like that because of time.
Yep, but that's fine. Look, it says we'll accept fractional decimal.
Hmm.
There we go. And it's only worth 1 mark. So if you just wrote 29, then you would have not got a mark. But because you write 29 over 100.
29 over 100, yeah.
Yeah, so that's perfect. Perfect. And then we have the bit at the end where we're asking to work out the big fraction, take away the not so big fraction. We change them both to 400. We subtracted the 2413 by 950 and we got 1463, which we did. We changed it back into a mixed number, but you would have got all marks.
Yeah, even if you had left it at 1463 over 400, right?
Yep, you'd have got the whole mark. Look, it says there, look,
accept. I would have left it there. I wouldn't even bother making it a mixed number. Anyway.
Because it doesn't say, please put your answer back into a mixed number. So yeah, you're quite well within your rights to put it in there like that. I can't even find it now. It's that one, isn't it? It doesn't say, put your number as a mixed number. It doesn't say that. So yeah, if you don't have to do something, don't do it. Right, and that is the last non-calc official. So what I'm going to do from tomorrow is start really honing in on those calculator papers. And it might be that we don't fit a whole one in an hour session because it's designed to be an hour and a half. However, we might kind of almost fit one in and then have to do the next couple of questions the next day. We'll see how it goes. But my plan is to now switch into, I'll do the level 1 non-calc, probably my own time today, put that one out, and then we'll start literally homing in on those non-calcs, those calcs for, keep scrolling down, for these ones here. I'll start back at the top again, and I'll
So
click on here.
if I may ask you, Steve, between the non-calc and the calculation papers, which one should we pay more